Hello everyone, this is Srividya, Assistant Professor, Department of CSIT. In this session, I am going to discuss about binary search in C. It is one of the searching techniques in C. In the last session, we have seen linear search, how a linear search will work, what is the working principle of the linear search. Linear search is a simple searching technique that we have seen. If you want to search for the given element in the list, what you will do? You will take a key value and you will identify all the elements in the array. You have to compare with each and every element in the list. If the element is found in the list, what it will return? It will return the exact index position. So with a sample program also, I have discussed what is linear search. So in today's session, I am going to discuss what is binary search in C and what are the advantages with binary search, what are the disadvantages, what is the definition, its working principle and time complexity of the binary search. So, binary search is an efficient comparison-based searching algorithm used to find a target value in a sorted array or in a list. Binary search is an efficient comparison-based searching algorithm used to find a target value in a sorted array in a given list. See, what is the difference between linear search and binary search? In linear search, as we have seen in the previous example, you will take if an array is given and you will compare with each and every element in the array whether your key value is present in that array or not. But in binary search is also same. You have a key value, you will search whether the element is it's there in the list or not. But the process what you are going to take is different. So in this first thing in linear search, the array should is there no rule like that the array should be in sorted order. But in linear search, in binary search, your array should be in sorted order only. Then only you can apply or you can implement binary search technique. So the first rule here is your array should be in the sorted order. Then only you can apply binary search technique on the given array elements. And the working principle, how it will work. It starts checking by the middle element of the array. So that value you will call as the mid value. And if the target is equal to the middle value, it will return the index. If the target, whatever you are checking, whether that value is there in the list or not, then it will return the index value. If the target is smaller, repeat the search in the left half of the array. If the target is larger value, then repeat the search in the right half value. So whatever the points I am kept here, that I'll explain with an example. This process continues, halving the search space each time until the target is found or the search space is exhausted. So the time complexity of the binary search, for the best case it is order of 1. For the best case it is order of 1 and average and worst cases are order of log n. And the space complexity is order of 1. If it is a recursive approach, it is order of log n. The advantages of binary search are, it is very efficient for large data sets with order of log n time complexity and requires fewer comparisons only, because you will not search for the entire array, okay, especially with large sorted array. In search, requiring no extra memory for sorting. Disadvantages, only works on sorted arrays or lists, not suitable for unsorted data without pre-processing. Requires knowledge of the sorting order. So what is that? We will see with an example. Consider the example. So what is the rule? If you want to perform the binary search on the array, the elements must be in the sorted order only. So this is your array. Now we will start comparing compare the value. So with the key value, consider the key value is 50. Okay. So here we have 3 cases. What is that? First one, key less than A of mid key greater than A of mid, and third case key equal to A of mid. So we have the three cases. So first thing, low, high and mid value. So this we have to follow. So first low is 0. Low is initialized to 0. High will be 10. So low value is 0. High is 10. So I am writing here the index positions. So how to calculate the mid value then? Mid is equals to low plus high by 2. It is 0 plus 10 by 2. That is 5. So mark here. At A of 5 is equals to mid. What is the value at A of 5? 30. So now you have to check this, which case falls under. So we got the first mid value as 30. So what is the key value I have taken? It is 50. So the first here, key greater than A of mid. What is my key value? 50. 50 greater than A of 5. Mid value is 30. 50 greater than 30. Yes, it is true. So now by this what we can say? Here you have the mid value and your key value is here. Here you have the mid value and your key value is here. So what you are doing? You are moving towards this direction, means low is incrementing. That is low is equals to mid plus 1. That implies mid value is 5. 5 plus 1, that is 6. So now your low value is 6 and high value remains as it is. So this is your first one. Whatever you are checking with the key value. Next. Now your low value is 6, high value is 10. Now again if you apply, mid is equals to low plus high by 2. It is 6 plus 10 by 2. 6 plus 10 by 2, 16 by 2, that is 8. So your mid value is 8. So at A of 8 is equals to mid. So what is the value at A of 8? That is 60. So which category it will fall under? Key value is 50. Mid value is 60. Key value is 50. So 50 less than 60. So this case, the first one, 50 less than 60. So your mid value is here. At the 8th position, you can say your mid value is here and your key value is here. So what it is? You are moving towards this way. Means high is equals to mid minus 1. Because you are decrementing. This way you are moving. 8 minus 1, 7. Now low remains as it is. High has changed to 7. So this is your second case. Now third one. So you got low value as 6, high value as 7. 6 plus 7 by 2. It's 13 by 2. That is 6. At A of 6 is equals to mid. That equals to 40. A of 6 equals to mid, that is equals to 40. So now you got here mid value here. A of 6 is equals to mid, that is equals to 40. So which case it will fall? We have the key value 50 and you got the mid value as 40. So it is 50 greater than 40. Second one, 50 greater than 40. So means you have to move towards low. Low is moving. So low is equals to mid plus 1. So here we have to mark here. This one is 6. Low is equals to mid plus 1. 6 plus 1, that is 7. So now low is 7. High remains as it is. if you again apply 7 plus 7 by 2, it's 14 by 2, that is 7. Mid we got at 7. So at A of 7 is equals to mid. So what is the value at A of 7? 50. So here you got the mid value and your key value is also 50. So which case you will check? Key is equals to A of mid. So my key value is 50 is equals to A of 7. A of 7 means the value at A of 7 is 50. 50 equal to 50. Yes, condition is true. So where you got the mid value, the key value at the index position 7. This is your binary search. So what we have done? No need to search for the entire array in the list. So based on this mid key value or the mid value, you will calculate whether the element is present in the left to the mid or it is present at the right to the mid. So this is the process will follow for the binary search. So let's discuss with the program. So after hash include stdio.h int main int a of 100, the array declaration I, low, high and mid, those are the declarations we have made. Printf enter the number of elements, scanf %ld comma address of n. Printf enter the number of elements. Suppose my array contains 10 number of elements or 11 number of elements. So that I'll enter it in runtime through scanf function. So scanf %ld comma address of n. Next printf enter the elements into the array. Printf enter the elements into an array. How to enter the elements into an array? For I is equals to 0, I less than n, I plus plus through scanf function address of a of I, you will give the input. Now we need one more statement, one more printf and scanf statement. Why we need that? To enter if you take the key value, you have to check whether the element is in the left to the mid or right to the element. So based on that, you need to produce the key value also. So that key value I have given as the input. And if you observe here, low is initialized to 0 and high is initialized to n minus 1. Low is initialized to 0, high is initialized to n minus 1. So, the largest next index position here. While low less than or equal to high. This condition you have to check every time. So then only you will calculate mid is equals to low plus high by 2. If key is equals to A of mid, found equals to 1. So here we have taken one variable found, that is 0. Initially it is set to 0. If the element that is found at the position, it will set to 1 and break. So if we want only one element to be print, so that's why we have used this break statement. Else if key less than A of mid, high is equals to mid minus 1, else low is equals to mid plus 1. So what we have done? So first we have checked if key is equals to A of mid. If key equal to A of mid, you can take flag value also. Flag equals to 1, break. Else if key less than A of mid. What happens if key is less than A of mid? If key is less than A of mid, high is equals to mid minus 1, else low is equals to mid plus 1. So suppose in the first case, low is initialized to 0 and high is initialized to 10 and mid value. So in this case, if key 50 equal to A of I, something, for whatever the value we got. So what we have done, the control will not enter into this if condition. Else if, so you will check whether key 50 less than or equal to A of 4. So that either this case will execute or this one will execute. And if flag equal to 1, equal to 0, element not found, else printf element found at position %d. In the previous case, what we got? Element found at the position, at the mid position 7. So this is the program, and you will search only for the, based on that mid value, you will search either in the left sublist or in the right sublist. It only works on the sorted array. So the difference between this here in the linear search and binary search is, if you want to perform binary search technique, the array should be in the sorted order. So that's all for this session. In the next session, I am going to discuss files in C program.